Redesign and Baileigh both started on the same path at the same time, right around 1998. So I'm building tubing benders, but I always had in the back of my head that I really wanted to do what we were doing when I was working for Mark and building these power hammers. Mark at that time had all the legacy machines. He had a big Yoder, he had an Echoed Craft Former, the kick shrinkers, Pullmax, all the machines that you see nowadays. He was the only guy around that had that stuff. But I'm like, well, there's, you know, I wanted to do this stuff. I wanted to have these machines, but there was no way I'm going to fit a giant K90 Yoder in my garage. It's just too big. It doesn't make sense, and they're hard to find. They're super expensive, and you got to rebuild them, and most of the time, and refurbish them from nothing. So I'm like, boy, it'd be really cool to have a machine that the average guy could have to put in their garage that can do all the functions of power hammer work, Pullmax work, and that's kind of where the MH19 came in. I had it stuck in my head that I wanted to build a machine to do that type of work. So the years went on, my company was being successful. I was able to design and work on other products, so tubing notchers and all that stuff, that was our core business. But then I decided, well, I'm going to build a power hammer. I want to bring back from the dead what I had learned back in the old days. And so I started designing the MH19, and I'm like, oh, I'm going to design a machine that can do power hammer, Pullmax, and all these functions into one machine that can fit in the garage and plug into a 220 wall outlet. And that's what you have right here, voila. So around 2010 was the first prototype MH19 machine. So Mark, again, at that time was doing Ford GT conversions. And I would bring him the power hammer in prototype state, and I would say, here, Mark, take it, beat it up, see if you can break it. And he was good at breaking it. So he ran it hard and was able to find all the weak links for it. And throughout those years of development, we fine-tuned it and got it into what the machine is today. It goes in power hammer mode and Pullmax mode. Power hammer mode means that this top ram is on a spring. So as I run it with acceleration, the faster I run it, the more this top ram whips or throws and hammers into the bottom die. If I don't want to do that and I want to do fixed stroke where this doesn't float on a spring, where it's just fixed height goes together, then I put in a pin up here. So we have a pin that comes with the machine, and it's a shear pin. So this just goes in there, basically deactivates the spring, and then the machine will run in a fixed motion. The other unique thing about the machine is I wanted to be able to adjust the stroke and have quick height adjustments versus like the Yoders and the legacy style machines. To change your gap, you have to put shim blocks in. To change your tools, you have to pound wedges in. So I wanted to eliminate all that stuff and make it user-friendly as possible for a machine that's trying to kill itself. So I made quick change tools with just quick pins that pop out. The stroke is adjustable just by turning a lever. You can adjust the stroke, and I'll get into that stuff a little bit more. Your height gap adjustment is all done with a lever. I put a hand wheel on it as well, so you can set your tool gaps and make sure that the downward stroke is where you want it. So those are all features that I planned for and built into the machine. So MH19 comes from, MH stands for multi-hammer, 19 is the throat depth, so it's 19 inches from here to here. And that accommodates most jobs unless you got a giant hood. We also have a nice open clear area down here. The handles are removable. We have a variable speed, a frequency drive to control the motor versus a clutch, a cone clutch like is on the legacy style machines. So with this one you can, with your a varying foot pedal, you can vary your stroke. The faster you go, the harder it hits, and you can see that with the demo. So what I'm going to do here, this is always a good demo. It kind of gives you an audible. I'm going to turn the machine to its lowest stroke. And the stroke adjustment is real handy, like especially you're going to find, we're going to be making this hood scoop. You guys are all going to have a chance to make this if you want. If I were to have the machine wide open and hit it in its most powerful fashion, that would be way too much for the aluminum, and I'm gonna stretch it more than I'm going to shrink it. So having adjustability is really handy when it comes to shaping steel versus aluminum. So with the stroke set to its minimum, with your ears, I'm going to run this, and then you're going to be able to hear. So you hear that, that compression on how it's hitting together. So I'm going to gradually increase the stroke, and then with your ears, you're going to hear how much harder it starts to hit. Okay, so you can see audibly how much more power it has as the stroke increases. So there's two ways to get more hit on a power hammer. One is stroke, the other is speed. So you combine stroke and speed together and you get a massive hit. And if you don't want a massive hit but you want speed, then you can slow the stroke down and increase the speed. And then you can use it like for planishing and stuff like that. So the door is wide open with the MH19 on the ability to shape different materials. That's one of the biggest keys. So also with that are the tool changes. So tool changes are tool drops out, pop the tools out. They have cross drilled, so you don't do it a lot, but if you ever needed to get in here to go sideways, they're cross drilled tools as well. So you can put them in there either this way or this way. I know that we're going to be making that next, so I'm going to be prepping it and putting those tools in that I'm going to use for that. So we'll go into description of that shortly. Okay, so what I'm putting in now, it's called a flat top master die. So this die is used almost exclusively for all of your stretch work. So flat top master, and then in the lower tool we'd put our crowned dies. And they're all labeled on the side, tells you what they say. This says flat top master, and all the others will be their corresponding radiuses. So 36. So that's a tool change. That's pretty speedy. And then gap-wise, I always like to run between an 1/8 and a 1/4 inch gap, almost for everything. So that's just kind of a rule of thumb. So it comes with a fence as well. So there's a fence that comes out as a guide fence, and that's used more when you're doing rigid mode, but you could use it as a stop as well. Say you're shrinking into a certain depth and you want to hit a stop. It could be used for that. So the door is kind of wide open on how you want to use the machine. So when the machine is in rigid mode, here's an example of some of the tools that you'd use for rigid forming. So this is for putting like a hat shape into a panel. So these would go in there, rigidly put it together, send material through that with a fence or a guide, and it's going to put that profile in it. You can use a separate fence, or you can build the fence into your tool as well. So I don't have any that have the fence built in, but a lot of people would just either bolt on a tab or weld a tab onto here to your set offset, and you can use the tool itself as the guide, which is handy. So these are screwed to what we call universal tool holders. So it's just a slot, a 1/2 inch slot. So that's for the user. You guys can take any 1/2 inch material, cut your profile, male and female, put them in these holders, and you can slide them side by side to get your adjustment proper and run whatever profile your heart desires. We're going to make this Cobra hood scoop. For this demonstration, so we're not here all night, I don't take it to complete finish, but I take it to a roughed in hood scoop. So this will be an option that you guys can make for your projects tomorrow. So this is the pattern that we use. So I had already, this is from the last show we did, I made a template here, so a basic template, and it has all the key things that I want to do to this piece of metal. So I have all the important stuff marked on here. I got where I'm going to shrink it, the center line of it, where I'm going to low crown stretch it, and I'm going to walk you through the whole process. We're going to start off is I'm going to transfer this data to this pattern, and I like to use a center punch. You don't have to use a center punch, but I like it because the dimple that you put in the metal stays in the metal even after you're shaping it, where a marker mark would disappear. And then when you can always come back to it and kind of gauge if you're still on when you're checking your part. So I like to start off getting it centered on the template as best you can, and you know, if we were doing this super accurately, you know, I would tape it on there, but for the sake of time, so I'm just marking all the highlight points. So you guys are going to use this, if you want to make a hood scoop, you're going to use the same template. All the tools will be here on the table. So I'm transferring what I'm transferring here is the highlight mark for the mark for the highlight line. That's basically the center of this radius all the way around.
You guys can gather closer if you want to, Chris.
So my marks are transferred, and now I'm going to transfer my areas that I know I need to shrink. And I know this all because I've made this thing a bunch of times already, so I kind of know what needs to be done. So these are the important marks, so you can just put little references so you can find your dimple marks. So this is, from this area is shrink. First thing I'm going to do is I'm going to put this low crown on here. So what that does is that basically keeps me from starting with a plate that doesn't have any form to it at all. So we're just going to lightly brush over this to give it a starting point. So I like to, you know, draw in the area that I'm going to work. And I try not to go down the middle because that'll draw around on itself. So this panel, in all reality, is very flat. So if we lay a ruler on it, so there's really not much to it at all. So, you know, it's basically flat. So I give it just a little bit more because I think it looks better. So I just give it a little bit of crown. So yeah, it's pretty flat. It's stayed. So that's pretty much all I put in it just to get started. So you see it kind of holds its shape now instead of just being a floppy panel. So we are going to have to shrink in here too, but I wait until these are done till I see what that needs. So shrinking, we're going to use thumbnail shrinking dies. So these are the minis. So we have three sizes of thumbnail shrink dies. We have minis, mids, and the standards. So this would be standard. And if I were to shrink with that on there right now, it would be way too much and the part would be ruined. It would shrink way too much, way too fast. So I need to bring it around gradually. If you look at this part, this isn't very much that I need to shrink. So it's only like 4 or 5 passes, if I remember right, that I go around there. And that's enough to draw that around. So when you're making multiple parts, that's one thing is the machine is very repeatable. So if you make a part once, you can make it again if you kind of remember your roadmap and what you did. Okay, 99% of the tools are all the same thickness instead of the minis. So the minis, you have to adjust your bottom depth or your tool gap. So that's one round of shrinking, and you can kind of see from the inside how it started to suck that together already. It's actually hitting a little bit too hard yet for the aluminum, so I'm going to soften it up a little. So I say that because with aluminum you got to be a little careful because you can shrink and stretch at the same time and not know it. So if you're shrinking it and you're hammering so hard to hammer the tuck out, you can actually stretch the tuck back out. So it's a happy medium on hammering it just enough to close the tuck. It is. It's creating the tuck and then I'm hammering the tuck out. So I'm watching, I mean, if I've done this a lot, so it's a lot of times I don't explain what I'm looking at or what I'm doing. So I'm looking in there. When I'm watching it, I'm watching the tuck. And I'm watching the tuck get to this line. And as it got, and I watch that tuck hit that line and I pull it back. I watch the tuck hit the line and pull it back. And like I say, all you guys are going to be able to experience this tomorrow. And I guess from as many times as we've done these shows, the hardest thing for everybody here that hasn't run a machine is the eye-foot coordination part of this and the throttle control. Everybody can kind of see what they're doing, but it's the getting your foot to throttle the hammering machine at the right time. So what happens is, I see it all the time, is everybody will just mat the pedal like it's a gas pedal wide open, go in and out, and then they end up with what's called coining on the outside here. And if you hammer so hard when you're exiting, the hammer hits and it squeezes the end so tight that it creates a coin that pops out, and they're like razor sharp, and you can slice yourself. But it's going to happen, and don't be frustrated. It's just getting used to the machine and learning how to control the throttle. So I guess a good recommendation is when you first get up to the machine, just take a piece of scrap and mess with it a little bit before you start doing your project right away, just so you don't get it too, because I try to bring, I can try to save almost everything everybody makes, but sometimes I can't save them. So you see that one is smoother than the other side because I turned the stroke down. So that's a good shrink to me. You know, I like that. That looks nice and smooth. So I'm going to keep going, and if I remember right, we'll check it on the jig a couple times, but I'm going to do like 4 passes. So that's 1. I'll do 3 more on each one, and then we'll check it. Consistency is huge in doing this. So you don't want to work in one area and just keep working one area and one area. If you got a part that has a whole bunch of shaping and forming on it, you want to work your way around the part and do it in a process that's thought of before you start, and just don't go to town in one area, because you can get one area good and then it'll mess up the other area because you weren't looking ahead. And you know, a lot of this is advanced for what we're going to learn here in a couple days. So we try to keep the project simple that everybody can attain and walk away with a nice finished piece. So you may not be able to hear it, but I am feathering the throttle control very, very minutely. So I'm not even close to being wide open with it. So I'm driving by my ears. I'm listening. So there's a certain sound that you know that that tuck is closed. And I can't explain it to you, but I just know it and you'll know it when you hear it. You can just feel that it gets solid.
As you're hammering, are you pulling down?
Okay, yeah, I am. As the tuck increases, I start to pull down ever so slightly. If you don't do that, you can reverse it, and you can end up with a little bit of a mess. If you go in relaxed and come out relaxed, it can actually potato chip on you and start to flip up. So when you're going in with your tuck, you try to stay as level as possible, and when you're coming out with the tuck, just ever so slightly down pressure. And you manipulate that. That's kind of a loaded question because there are instances as a tuck gets really deep in a really sharp corner where you're really pulling down, you know. So for this project, I'm not going to be pulling down very hard. But there are instances where you do pull down pretty hard if it's a real deep, really tight radius shrink. So that was 3. This will be the last one, and then we'll check it. We're going to lay it on here, and you can kind of see. So a lot of this, see, it doesn't lay just perfectly because of the flanges on here. You can kind of see. Actually, I didn't bring the tool along, but last time I brought just an angle gauge, and I would check that angle, and I would transfer it. And when my angle was close, I knew I was there. But I think we're pretty close. So you'll see that this front piece now, okay, that's popped out. So now I need to shrink this just a little bit. So I always shrink that last so I can see it pull around and see it match this curve. Okay, so I got the ends where I want them. Now I'm going to shrink in the middle here to just draw that down and make this flow all the way around at about the same angle. And then I didn't mark it. Like Mike marks all his shrinks because he's doing a more involved project, but I'm stepping over about 1 inch every time I shrink. So inch, about-ish. Where Mike, when he does his are laid out and he goes into a specific area every time. But this is such a small area that my marks would all be gone already anyways. So that was like 1 pass around there. I think I'm going to give it like just two more in the middle, and that looks like it would tighten that right up into where I want it to be. Oh, sorry. And you can overshrink it. I mean, if it's overshrunk, we can stretch it back a little bit, but if it's way too overshrunk, then you got to start over. All right, so that's where we're at with the shrinking side of it. Now what we're going to do is we're going to go over to the English wheel, and we are going to put this form in it right here. Seeing this is a gradual radius. I checked it before we had started, and it's about a 2.5. So 2, 3, so it's in somewhere between 2 and 3, so it's a 2.5. Normally when you have a hard wheel up on top and a hard wheel on the bottom, you actually linearly stretch the metal as you squeeze the 2 rollers together. But what we're doing here, we're not changing thickness. We're just putting this shape into this panel. So I'm not stretching it at all. So if I were to do this with a hard wheel at the top, I would put that shape in there ever so slightly, but this part would crown like this then, because I stretched it. I don't want to stretch it. I just want to fold it over to that radius. So, like Mike will say this tomorrow too, you're kind of either a hammer guy or a wheel guy. So the English wheeling a panel is black magic to me. Power hammering, it has function, purpose. You tell it what to do basically, and if you do it in that process, it does it right. English wheeling is more of a magic. Some people have it, some people don't. I don't have it so I use the English wheel almost primarily in this fashion for putting form into a panel. I'm going to do a couple passes here, so I'm just putting pressure on it with the bottom. So I'm basically pushing this lower roller up into this rubber die, and the metal's trapped in between. So I'm running it right on that center mark that I put on there when we were at the table. So I just push it right until it hits there. So that's one pass. So we're going to do a couple passes, but I'm going to do it on each side so I get the even amount as I am doing it on each side. So I got a fair amount of pressure on it. I don't know if you can see me, but I'm putting a little bit of force on it to get it to where it needs to go. Okay, now I'm going to increase it. So now I got quite a bit on it now. And this one I'm letting the machine do the work. I'm not really manipulating it at all other than pushing it. And this is all based off that pattern too. So if I wouldn't have had the pattern, I wouldn't know where to put this raised area. That got me started. Now to finish it off, I'm going to do it with muscle. And I have this piece of tube clamped to the table over here. So the rest of it, I'm going to push over just with body weight. Yeah, I knew this was going to be a little tight over here. So not everything is done on a machine. Now you'll see that there's some puckers in here, and here. So that means it needs a little bit more shrink. So I need to tune that up a little bit. Then we're going to go to a planisher, and I'm going to planish in here to get that radius a little crisper. And then we're going to tip this flange on it. What we're going to do now is we're going to go back to the power hammer, and I'm just going to shrink these little areas that are bumpy a little bit. So I'm only going where the material is telling me to go. So if there's a bubble or a pucker, that's what I want to get rid of. That's it, simple as that, and it tightened it right up. For what we're doing, that's as far as I'm going to take it. So you could take it more and get it to be like a mirror. But for the sake of time, we just like to get through the project. So next, I am going to mark the flange. So we're kind of cheating a little bit with this project because we have the templates pre-cut almost to exactly what you need. So when we cut the flange, I just use 3/4 inch tape, and we run right along the tape edge, where if it was an actual part that you were making from scratch, it probably wouldn't be cut as accurately as these. So after this, we're going to go over to the bead roller, and then I'm going to tip it by hand. All right, so that's my edge where we're going to flange it, and that's going to create this flange along here. And that's going to fold that up. So on the bead roller, So I have the die set up here. This is one I brought from my house. This is a 16th radius die, so it's an 1/8 inch diameter roller. I like that one better for tipping an edge because it doesn't put such a severe crease in the metal, and it's a much milder way to tip. So this machine has a quick release on it, which is real nice. So I'm going to get the first pass. So this is going to be done in multiple passes. The first pass is kind of a guide pass to put an impression in the metal. So once the impression is in the metal, subsequent passes are much easier to follow. So this first pass, I'm only going to be putting really light pressure up on it. So now this is my guide pass, so I'm following that line. And I'm putting, if you can see me, but I'm putting a little bit of up pressure on it, just a real little bit, just so I get that impression put in here. So we're actually going through a bunch of metal shaping techniques all in one part, and that's kind of why we chose this part. So we're doing a little bit of everything. So we're doing some overall hammering, we're doing some shrinking, we're doing some bead roller work, some tipping. We're going to be doing some hand work at the end. We're also going to be running a bead down the middle in rigid mode. So this piece lets you touch almost every aspect of metal shaping. So when we first started these classes, we used to make a bowl, just a simple bowl, and that was my demo, but a bowl is boring. It's good for learning. I mean, it is good for learning and technique and control on the power hammer, but your end result is boring. What do you do with a bowl, you know? So this is at least something you can hang on your wall or screw it to your Pinto outside and And the way I'm demonstrating making it, and that's almost everything with metal shaping, is there's no right or wrong way to make a part. This just happens to be the techniques that I chose to make it. So we had some guys in the class that made this whole scoop and didn't use one of my techniques. They did it all on a kick shrinker and a sandbag, and they made a perfect looking part. So that's one great thing about metal shaping is there is no right or wrong way. It's whatever method you follow and whatever techniques are good for you. So that pass right there is just to set the line. Okay, I didn't really do anything other than put a little impression in it. You can see it from the backside, a little impression. So now this next one, I'm going to give it some more mux. I'm going to bear down on it a little more pressure, a little more pull, and I'm going to be able to get that flange to wrap around. So I'm going to go quarter turn. And now I'm pulling up on it, so I'll let go and you'll see, that's how much I'm pulling up on it. But now my line is much easier to follow because I have a crease in it already. The back looks good. I need a little bit more right here. All right, so we have the flange. So I'm going to clean this up now with a hammer on the edge of a table, and then we'll get that laying nice and flat, get it to lay as flat as we can. So now I'm just hammering out the imperfections. So what we're going to do next is we're going to go to this hammer form here, and we're going to form the front edge. So we're going to roll this edge around. I like to use my slapping hammer to get it started. And I do this because it doesn't put a bunch of dents and everything in the metal right away. But eventually, it takes a little bit more oomph to get it to go around, and then we have to use a metal hammer. So it's kind of like same with in the power hammer. You can't do everything in one spot. If I do everything right here, it's going to mess up over here. So you gotta kind of walk it around and follow it. And then it turns into what I call, it's kind of like whack-a-mole once it starts popping up and peaking. So it's actually shrinking. It's shrinking that flange. I'm basically doing the same thing we were doing in the power hammer, but I'm doing it with a hammer here. So you can take this and tune it up. We could tune it up with a dolly by hand behind here and get that to fold over more. Or if we wanted to wire edge it, we could wire edge it at that point. But that's the basic idea of a hammer form on the front. Next, I'm going to drill 2 holes, and I'm going to cleco in a guide, and then we're going to put a bead right down the middle of this in power hammer mode. Okay, these are the dies that we're going to use to put this impression in here. You'll see it's a 1/4 inch bead, and you can kind of see that that's going to. We can do it 2 different ways. There's no right or wrong way to do it. Either we can run it upside down and pound the bead in, or run it right side up and use the top die to push the bottom tool in. It works the same either way on this particular die. Okay, so we know that these dies are 2 inches. So I need to mark 1 inch off center, and then I'm going to screw this guide to it. So seeing we put them center punch marks in there, that comes in real handy right now. So I wouldn't use such a big cleco for this, but that's what we have. And then we are going to put this thing in rigid mode. So drop the lower. And this is where the indexable tooling comes in real handy, or if you want to run forwards or sideways, you can index it 90 degrees, however you want. Check our tool gap. So this one is a little different than, so we're actually going to set the tool gap to the material thickness on this project. If it was a real aggressive profile, you may have to step your way into it. So meaning you might start at a 1/4 inch, creep it down, creep it down, creep it down, and do it in multiple passes to bring the profile into where it needs to be. But seeing this is one impression, it's real easy, it goes real fast. I can do it in one shot. So the pin goes in up here, and that locks out the spring. So now the machine is rigid mode. Okay, so that pin up there, it serves 2 functions. One is it locks the machine out of spring mode, but it also has, I didn't show it to you in detail, I can't here. But it has grooves cut in it, so real deep grooves. Those are cut in there on purpose, so if you do set the machine up potentially wrong, and you have the tool come together and it crashes in itself, it'll break the pin and not break the machine. So it serves 2 functions. It's a shear pin and the pin that puts it in rigid mode. This is one of those deals where you want to run it on a short stroke. So the longer the stroke you have, so I don't know if you can see in here, you'll see like an impression, boom, 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 boom. So that's a function of how high the stroke is and how fast you feed it. So if you want a real smooth finish, you try to go as low a stroke as possible and feed it as slow as possible. Then that way the closer the bumps will be together and you can get almost a zero bump finish. Before you run a potential profile in a part on a die you haven't tested yet, it's always good to run a test piece to make sure it's making the profile that you want. And we'll do that with this one just for fun. When you set the tool gap on the MH19, this hand wheel's here for a reason, and that reason is to get the stroke to the most bottomward point of the machine. So that's as far as the machine is going to go down. So I'll set it there, and then I'm going to lower the top tool until this just makes friction. So right about there. So that's our material thickness. Now there's also two functions to run this machine. I didn't explain that earlier. If you don't want to use the foot pedal and you just want it to be on, you can just have it go on. And there's also a speed control. So that's why you want to have a fence. So that's freehand, and you can see it just wanders all over the place. So you'll see when we follow a fence, it's going to be nice and perfectly straight. So you try not to start and stop like I did there. I got a little bit of a bump, but I could clean that up by hand. There's the project. So that's the demo for now. Like I say, it's not taken 100%, but it gets you the idea of all the steps needed to make a scoop.
Now, if you went over that again with that,
You could smooth it up. Yeah, you could go over it again. You know, once you start I probably have 50 different profiles at home of different shapes to match things or whatever. Once you have the ability to make them real quick and easy, so it's easy to make that. To make a bead roller, well, you need a lathe, and if it's a complicated thing, you almost need a CNC, unless you're, fiddle farting around to dial in a shape. It might take you all day to make that tool. Where this, you can do it at the bandsaw on a file and have two mating dies in a really short amount of time. And they don't have to be perfect. You'll look at, these aren't perfect, but they did a great result in what I made it. I mean, I did in steel. Both of these I did in steel, and they gave a great result. If you're in aluminum, if it was an aluminum job, that probably would have needed to be polished more, so you wouldn't have. Aluminum transfers really easy, so any imperfection in the die gets transferred to the material. Steel's a lot more forgiving, a lot more. There's Rusch, everybody.